quality, and then we're going to build up maybe even earlier than intro. Okay, intro to applied pre-calc. So page 41. So now we're going to talk word problems. If you're given a word problem, you have to read and interpret the question in order to produce, right? You're going to have to produce the appropriate inequality. You're going to have to come up with it. An inequality essentially provides a restriction, right? It's basically restriction to possible answers to that question. That's what you're doing when you're coming up with an inequality. The things to keep in mind, the type of data that we're going to deal with. So we have our classic discrete versus continuous. Does that ring a bell? Discrete versus continuous? It comes up in other subjects as well, right? Like it's not just math specific. So when we have discrete, you need to round POIs, right? You got to make sure you do that. So example, when you're dealing with coins, with cans, people, cows, I don't know why I came up with that, but anyways, etc. We round POIs, right? We round POIs. Very important. So how does that work? So let's say you use your calculator. Your calculator is going to give you 6.918, let's say. Right? Yes, I want you to write it down the way you found it, but then for that specific problem, X might be the number of horses, Y might be the number of cows, right, in a farm. So you have to round whichever one is as a decimal. Maybe they're both as a decimal. You just make sure you round it to the nearest whole number. Okay. Continuous exists as a decimal, right? Partial amounts are okay. Partial amounts are okay, right? So you would think of, for example, area, distance. I just started, Micah. Distance, time, page 41. Temperature, you name it, right? Anything with a dollar amount, that's just fine, etc., right? Don't round. Speed, right? Anything that can be measured is basically okay, right? If you can measure something, it can stay as a decimal. So that's the first thing I need you to just remember, okay? Remember that. It's going to come up from time to time. So we just need to be mindful of that, okay? Next, almost all cases, that's not written properly, right? Almost all cases involve, let's just get rid of this. Almost all cases involve data that cannot be negative, okay? I'm actually gonna, I just did that almost all. In our case, it's always gonna be positive. But I can see that there are cases where you might have negative, but word problems usually don't. Therefore, your graph will be restricted, right? Graph will be restricted to the first quadrant, okay? And you will notice that there's something we call the implicit constraint, right? Implicit means we assume that X and Y are positive. That's what this little statement, remember domain and range, right? This is basically saying both your domain and your range involve values that are 0 or greater. Okay. So side by side, guys, no context, no word problem, context, word problem. How will they be different? Just like when we did the quadratic unit, as soon as you have a context around it, it changes. So let's make sure we put arrowheads on this one, right? All those dashed lines and whatever and solid lines, they go on forever. In this case, you only have one POI. This is your solution region here. Obviously, when it's a system, we use reverse shading. So this is your only POI there. I'm just going to tell you that that is 12, 9. We're just going to estimate that. Only one POI, because I told you that intercepts are not POIs so far. I hope you have a ruler handy. We're going to copy this. I couldn't do it with my software. I couldn't get rid of the shading, so I just inserted a grid. So try to copy this one. This one starts at about just above 10, like 11-ish. Make a dot there. And then that dashed line goes to 40 here. So just over 11 goes to 40. Make a dashed line there. Okay. And the other goes anywhere between 20 and 30. I think it's exactly between 20 and 30. And it collides here at 20, 0. Right? So anywhere between 20 and 30 here, and then right at 20 there. Notice that I'm not crossing the axes, right? I'm stopping. Stopping. So we shaded, if you look at the original here, this is what your calculator or whatever might show you. We shade everything below this line here. So we're going to put a ruler there, but do not shade outside into the negative. You kind of have to really shade between the lines here. And then we go to the dashed line, and I shade everything above that one because that's how it was on the original. Okay. So our solution region is here. And let's just call this, I just want to give it a context. Let's call this, we're comparing cars to buses. Just making that up, right? So cars and buses. Now we know there's a context around it. You actually, in this scenario, because you're bound to the positive quadrant, you have 3 POIs. Okay, so this one is 12, 9 still. This one is 20, 0. And this one is 40, 0. And I will do this, right? These are POIs in a word problem. Okay, same with the y-intercepts. If you had any y-intercepts, we would consider. So now the solution region, because it can only be in the positive quadrant, in this quadrant 1, everything surrounding that solution region is a POI. But if we hadn't had a word problem surrounding it, we would only have had one. We would not have considered these as POIs. That's all I wanted to say with this. So make sure you understand that. It has to do with the domain and range. Let's keep going to 40. And let's see here. 2 different highlighters. That's what I have. I'm going to go pink and orange. And then my regular yellow. Whatever you have works. You're either going to hate highlighters or love them after you're done with me, right? Okay. The first thing I need you to remember or notice, okay? Keywords. If you see up to, a maximum of, no more than, has a capacity of, at most, right? That would be y is less than or equal to. Or if you have at least, minimum, etc., you would have greater than or equal to. Okay. I feel like this wasn't done very well, but all these words would have this inequality, and all of these ones would have that inequality. And these aren't all of them, but it covers most, right? So write inequality for the following statements. Let x be the number of people. X will be the number of people. Y will be the number of pets. And some of these statements may not make sense in real life, right? Okay, just follow what I'm trying to do here. So you read this statement. A building can accommodate no more than 400 people. No more than 400 people. And so you're like, okay, write an inequality for that. This is what it would look like. We're talking people, right? So we would use the variable x, and the number of people has to be less than, right, or can be no more than 400. Okay, so this is the statement, this is the inequality that would fulfill this restriction. Okay, another way of saying this, no more than 400 also means $400 or 399 or 398. You get that point? Sometimes it's better to think of it that way. You can have 400, but no more than 400. So x has to be less than or equal to 400. That's another way of thinking about it. Okay. So I'm just going to highlight the fact that this is only dealing with a number of people. That's why you only use the variable x there. A dog park can hold up to 45 dogs. Okay, so this can hold up to. This is an indication that there's some kind of restriction. And we're talking dogs, right? So I'm going to highlight that dogs in orange because that's what I used for pets. I should have done people in pink up here. My bad. So can hold up to 45 dogs. So we will say, okay, the number of pets can hold up to, okay, that means it has to be less than or equal to 45. And I hope that makes sense, because if you think of this statement, the dog park could have 45 or 44 or 43 dogs. It could have 0, right? It can have no more than 45, right? Up to 45. Okay. Could also have read a dog park cannot hold more than 45. Could have been the same thing. Let's keep going. A dog park can have up to 100 dogs and owners combined. Uh-oh, okay. So we'll say this, can have up to, then there's your owners, right? People and dogs combined. So this is where I start to insert both variables. When you have that, you have to see it this way, that the number of owners combined with the number of dogs, this combination has to be less than or equal to 100. So you could have 99 owners and 1 dog. You could have 50 owners and 50 dogs, or you could have 40 and 40. It doesn't matter as long as it's less than 100. That's what that statement is saying, and this would fulfill that statement. Okay. And you're going to have to wrap your head around this one a little bit. Yeah. How about this one? A vet can see up to 24 pets per day. We're talking pets only. Can see up to 24. So that means that the number of pets that this vet is going to see has to be less than or equal to 24. So what did I use for pets? I used orange. Okay, there we go. A committee needs at least 5 members. The word at least comes up here. And members, we're talking number of people. How would you write this? X and 5, right? I think everybody would agree with X and 5. Which way does that thing point? At least it's saying that the number of members has to be greater than or equal to 5. And if you don't see this, think of it this way. Committee needs 5 or 6 or 7 or members. So this statement is saying, hey, whatever X is, whatever the number of people in that committee can be 5 or more. Okay? A stadium allows up to 20,000 visitors and pets combined. I was thinking of Caesar Milan filling up a stadium, right? I don't know if you know the dog whisperer, right? So people would bring their pets, obviously. So there it's visitors and pets combined, right? So we can say that people and pets allows up to 20,000 visitors. So these two numbers have to be less than or equal to 20,000. You can have 20,000 or 19,999, or right, like it, just think of it that way. I didn't do the highlighting, did I? So let's committee. I guess the members, I mixed that up, didn't I? Way to go, way to go. Way to confuse your students as you're starting this section. Sorry, guys. This was supposed to be pink. Pink here. Visitors and pets. There we go. I'll do this one and then I'll give you some homework. That's it. All you're gonna have to do is no graphing. That's the beauty. You're just gonna have to write out what that statement says as best as you can. Two numbers have a sum that is less than 20. Let's write a statement for that. When it's like this, you have to say, okay, let, right, x would be the first number and y would be the second number. You did something like this in IPR, most likely, but not with inequalities. I don't think so. You did something that where it would have said they're equal to, right? So two numbers have a sum that is less than 20. So we say this, x plus y, those two numbers, that would be less than 20. Okay? This is inequality 1. And then it says twice the first number plus 5 times the second number is at least 50. Say what? Okay. Well, let's write the second inequality. Twice the first number plus 5 times the second number is at least 50. So I'm just going to put the 50 there. Which way does that thing point again? At least 50. I want this side to be 50 or more. That's what that is saying. So you have to point it this way. It could also be equal to, because the word at least is indicating that it could be 50 or more. 50 or more. That's what that is saying. So sometimes rewriting that statement will help you. By the way, this example, I'm just going to warn you, this example would span all 4 quadrants. This is the one where you're not restricted to the first quadrant because we're talking numbers, right? It could be negative numbers. You could use negatives, perhaps, right? Like, so these types of questions, they don't happen very often, by the way. I don't do a whole lot of these types, but that way you just had an idea of how that works, okay? I don't know if you want to go arrow like this and arrow like this. Those are the inequalities. So this is now a system, technically. This is a system. We could graph this and figure out where could I possibly find numbers that would meet the criteria. Homework. Please do it. Please try it. So you go to page 44. I'm gonna say page 44 and 45. Do as much as you can. 44 and 45. I will post the key to that. Thank you guys. See you tomorrow, Friday. Yay.